Today we're looking at proportional and non-proportional relationships, particularly when we're looking at tables and graphs. And then we're going to be taking the relationship and writing an equation to describe it. So there's a proportional relationship and there's a non-proportional relationship when explaining an equation. So you have two forms of those. The first form, when you have a proportional relationship, is going to be what we're used to for that we already learned this chapter, which is called direct variation, and it's in the form y equals kx. Then you have a non-proportional relationship, which would be written as y equals mx plus b, and that would be also called slope-intercept form. Now, to determine whether a proportional relationship is proportional or non-proportional, you want to look at the values that you're given, whether it be a table of values or whether it be a graph of values, and you want to look at each ordered pair and write a relationship for it, x over y, and if each ratio that you write is the same value when you divide x divided by y, then you can consider that a proportional relationship. So you would use y equals kx. Now if it's non-proportional and that is not the case, then you would use slope-intercept form, which is y equals mx plus b. So we're going to do a problem related to figuring out whether it's a proportional relationship or a non-proportional relationship, and also graphing and making an equation from it. So we have a professional soccer team that's donating money to a local charity for each goal they score. And we're going to look at the table, and they have a number of goals is listed at the top, 1, 2, 3, 4, 5. And the donation money is listed at the bottom, so 75, 150, 225, 300, and 375. The first thing we need to do to determine how to graph the data is figure out which values are our x values and which values are our y values. And we can determine that by figuring out which is the dependent variable. So if you think about the number of goals depending on the donation money, or the donation money depending on the number of goals, well, each goal scored, money's donated. So the donation money is going to be dependent on the goals, or number of goals scored. So that makes x our number of goals and y our donation money. So once we've determined that, now we can think of each column as an ordered pair. And that's what we're going to graph. So we have 175. I need to make my graph first, label my axes, and then I need to figure out my scale. So my scale for x's could just be, since it's the number of goals, and we only have up to 4 or 5, I think. We can go by ones, and that should be fine. But then each goal scored gets $75 donation, so we would probably want to go by 75 for the y values, since that's our donation money. So we have 75, 150, 225, 300, and 375. And we're just going to plot the points. So you would be doing this on graph paper, so it's a little bit more straight, but you would plot 175 from the table, and then 2, 150, 3, 250, 225, 4, 300, and 5, 375. Whoops. And then we would connect the line. And again, yours should be a little bit straighter than mine because you're using graph paper. And we have our graph. Now, if you think about the graph and the table of values, we need to think about what can we deduce or what can we figure out from the pattern about the relationship between the number of goals and the money donated. Well, we can look at each goal. It looks like you're getting $75. So that's what we can deduce or figure out from the pattern. So each goal donating $75. Now we're going to use the same table and write an equation to describe the relationship. So we need to figure out whether the relationship is proportional or not proportional. So we're going to make a ratio of each x over y. So we have 1 over 75, 2 over 220 or 150, 3 over 225, 4 over 300, and 5 over 375. Now, if I divided each of these in my calculator to make this easy, I would do 1 divided by 75, and then I'd get a value, and 2 divided by 150, 3 divided by 225, 4 divided by 300, and 5 divided by 375. And what I should get is the same decimal value for each of these ratios, which I end up getting. So yes, this is proportional. So since it's proportional, we're going to use the form for direct variation, which is y equals kx. And the k represents our slope, so we just need to find our slope to fill into our equation. So to find slope, you just need 2 ordered pairs. I believe the first 2 ordered pairs are fine, as long as the ordered pairs are next to each other or consecutive, then that should be fine. So if we take our ordered pairs and subtract our y's over our x's, we should get 75 over 1, which was also the pattern for the y values. So that's going to be 75, and that's the slope, which is the same thing as the k value, so we just plug it in for k and write our equation. So our equation is y equals 75x. Now we want to use that equation to predict how much money was representing with y will be donated for 12 goals. So we use our equation, y equals 75x. We're finding y when there's 12 goals. So we plug in 12 for x, and we get 900. So this means $900 will be donated for 12 goals. Next, we're going to write an equation, again in function notation this time, for the relation shown in the table. Remember, the only difference between an equation and an equation in function notation is that one has y equals and one has f of x equals, but it doesn't change anything else. So the first thing we need to figure out is whether this is proportional or not, so we can figure out which form to use, either y equals kx or y equals mx plus b. So we figure that out by making ratios. And then if we divide each one, 1 divided by 3, 2 divided by 2, 3 divided by 1, and 4 divided by 0, we would get not the same values. So this is not proportional. So that means we're going to use y equals mx plus b. But we still need to find the slope first, or the m in this case. So pick 2 points, 1, 3, and 2, 2, that are consecutive, and find the slope by subtracting the y's over the x's. You should get 1 over negative 1, or negative 1. So that's going to be our slope. And if we plug that in, we still need to find our b value when we have this type of equation. So our b value, actually I shouldn't erase that, can come from any point after we come up with the m value, the slope. And since this is the first point, might as well just use 1, 3 to help us find our b value. So I'm going to plug in 3 for y, 1 for x, and I'm going to solve for b. So I get 3 equals -1 plus b, and then I'm going to add 1 to get b by itself. So b would be 4. And again, that's not our answer. Our answer needs to be the equation. So the equation is going to have the m and the b in it. So we found that the m is -1. So you could write -1 or just -x. And our b value is 4, so we're going to say plus 4. And that would be our equation. Now, function notation, the only difference is I'm changing my y to f of x. And that's the difference. Now we're going to do one more where we need to write an equation in function notation, but this time it's for the graph. So we need to come up with the points that are here from the graph and make a table. That would probably be the easiest. So we have 0, 4, 1, 0, -4, 1, -2, 2, 0, 3, 2, and 4, 4. So if I'm going to determine whether this is proportional or not, I'm going to make each one a ratio. And I should be able to already tell that this is not proportional because our ratios are not the same value. So this is not proportional, which means we're using y equals mx plus b. So we need to find our slope, because either way you're going to find your slope first. Use 2 points consecutive, 0, -4, 1, -2, and subtract your y's over your x's. You get -2 over -1, which simplifies to 2 over 1 or just 2. So that's our m value. And then we plug in our m value and 1 point, doesn't matter which point, for x and y to find our b value. So let's plug in -4 for y, 0 for x, and we get -4 equals 0 plus b, or just b. So b is -4. So now we need to write our equation in slope-intercept form, which is y equals mx plus b. And it ends up being y equals 2x minus 4, or plus -4. And function notation would be f of x equals 2x minus 4. So this would be our final answer. And that concludes lesson 3-6.